Hello everyone, welcome to MITS seminar final presentation. I will be talking about the courses I have taken, but before that let me tell you about myself. I am Akifa Tasnim. I have completed my BSc in Computer Science and Engineering from BRAC University, that's in my home country Bangladesh. And after that, I worked as a software quality assurance engineer from one of the topmost companies in my country. And then I started my master's in IT security at Ontario Tech University. So I have taken two elective courses. One is network data analysis, that's conducted by Professor Amir Ali Abari. And another one is cybercrime, that's conducted by Professor Bernadette Sell. So between these two courses, I will be talking about network data analysis. Well, I found this course really an interesting one. Networks are a universal language for describing complex systems. Networks and IT security, I think they're closely related, as networks are the backbone of modern IT infrastructure. Network security involves protecting the network and its components from unauthorized access, attacks, and breaches. A strong network security strategically is critical in ensuring the confidentiality, integrity, and availability of data and systems within the organization. At first, let's discuss why network matters. If you want to understand the spread of diseases, can you do it without social networks? How about for spread of malwares over computer networks? You cannot do those without having a knowledge of networking. Can you understand the web without understanding its connectivity structure? Well, you can't. If you want to understand the dissemination of news or evaluation of science, it is hopeless without considering the information of networks. Effective transportation route design is one of the most important reasons why we need to know networks. Well, now that we know the importance of networks, let's see what were the topics that were covered in the class. Well, there are lots of topics that the professor taught us. Among them, I will be mentioning some which I enjoyed the most. There were methods and algorithms for collecting network data from social and information networks. There were graph theory. Graph theory is a branch of mathematics and that studies the properties and applications of graphs, which are structures consisting of vertices or nodes connected by edges or links. There were network formation, community detection, and the robustness and resilience of networks against attacks and failure. Now let's see some network representations, some directed or undirected graphs. At first, email network. Email network will be a directed multigraph with self edges, because when one person sends email to another person, the other person receives it, and whenever you open the mail, you can see if you have received the mail or you have sent the mail. So it's clearly a directed graph. Facebook friendship. Now, one person needs to send a friend request in Facebook to other person to become friends. So when the other person accepts that friend request, right after that they become friends, and there is no trace back that who sent the friend request until they remember it. That's a different thing, but you cannot really trace back that who sent the friend request. There is no archive or history. So this will be an undirected and unweighted graph. Citation networks. This is clearly directed graph, but that's unweighted because in when you cite one paper, you write one paper and cite another one paper, that's there is a trace that you are citing, you took some references from this paper, so you are citing this paper. That means that will be a directed graph. The collaboration networks is undirected multigraph or weighted graph. Mobile phone calls are directed multigraph because of course one person make phone call to another person, and there is a trace, like if it's an incoming call or outgoing call, that's why it's a directed graph. Moreover, we got to learn about a tool called Gephi. Gephi is a powerful open source software for network analysis and visualization that allows users to import, manipulate, and visualize graph data as well as interactive exploration. With Gephi, users can identify patterns, clusters, and communities within their data, explore network structure, and analyze network metrics such as degree, centrality, and betweenness. Additionally, Gephi enables users to create interactive visualization and export their results for further analysis or publication. Well, before I tell you what did I do with Gephi, I need to mention some of the keywords. Those are networks, nodes, and edges. Network is a collection of objects where some pairs of objects are connected by links, as you can see in this diagram, and nodes are the objects and edges are the connection among the nodes. Now that we are clear about these keywords, let's see what can be done with Gephi. Well, to draw a graph in Gephi, at first we need some data. So to collect data, professor asked us to write our name in this table. As you can see, there are labels. Labels are basically the name of the persons who attended the class. And then he generated some random ID for each person. So the labels are basically the nodes. Now, based on a scenario, the connections, as in the edges, will be created. So he asked that with whom or with which person we had at least a 3 minutes conversation with. Okay, so then we write down the name of the persons with whom we had 3 minutes conversation. So here's another screenshot of that collected data. As you can see that here the first person had a 3-minute conversation with 4 of these persons. So here the source is basically the node and the target is basically the connections of that node. So from these boring data, we came up with a beautiful graph with Gephi. As you can see that this is basically the graphical representation of our class with which person which person talked with another persons, something like that. So from this graph you can see that this person had the most conversation with other persons. So we can say that he probably is the most extrovert one who talks with lots of people, and these 2 persons are probably the introvert one. They don't talk that much. After doing this graph in Gephi, we actually discovered that the graph, whatever the graph is shown, it's correct. The person who I said that is the one who's extrovert, he actually used to talk most of the time. It's not like he was talkative or something, but he used to talk most of the time and respond to professors' answers and made friends and all. And these persons and the other persons, they were really introvert. So those graph make sense. And learning is fun when you can relate it with your real life, and that's why I enjoyed this class most. Let me show you another data that professor took, it was based on the scenario with that where he asked that with which person you shared your table with. Basically, in the class you shared with your table with. So just like that, the previous one, here the source, as in the node, is the source one is the node, and the target are the connection of the node, which means the person Kirtana, she shared her table with these three persons, Anuhya, Akifa, and Parisha. Just like that, the data goes on. This is just one portion of the screenshot of the data we took. Is the another graphical representation of that data from where we detected the communities. As you can see that the communities are there are basically three communities. The communities are detected within different colors. So yeah, this is how we represented one boring data to a nice graph with Gephi. As I mentioned before, we also learned about robustness and resilience of networks. Networks need to be robust and resilient in today's digital age, meaning they should be able to continue functioning even if individual nodes or connections fail, and recover quickly from attacks or failures. Redundancy, load balancing, security measures, and disaster recovery plans can be used to achieve this. Network administrators should implement a combination of these strategies to ensure that their networks remain functional and secure in the face of attacks and failures. There are several ways to increase the robustness and resilience of networks. One way is to use redundancy, which involves creating multiple paths between nodes or duplicating important components so that if one fails, another one can take its place. This can also involve using load balancing techniques to distribute traffic across multiple paths, reducing the likelihood of any path becoming overwhelmed. Additionally, network administrators can implement disaster recovery and business continuity plans to prepare for unexpected failures or attacks. This involves having backup systems and procedures in place to minimize downtime and quickly restore normal operations. Overall, building robust and resilient networks requires a combination of redundancy, security measures, and preparedness. By implementing these strategies, network administrators can help ensure that their networks remain functional and secure in the face of various types of attacks and failures. These are the references that I have used for this presentation. That's all of my presentation today. Thank you for listening.